and today we will be looking at multiplying polynomials. Now, this is my first video. Let's see how it goes. Right, so let's start looking at some examples first, and you can follow along with your handout as well. Right, so example 1, right, on your handout, I believe it says the following, right? You have 3x times x plus 3. Now what are we looking at here? We're looking at two expressions, two terms, right? What do we have? 3x here, and we have in brackets x plus 3, right? So what do we use to expand this, to multiply these two terms? We use the distributive law, right? Now if it helps you, you may want to do this. You may want to draw the arrows indicating that you're multiplying 3x times this term, so 3x times x, and then 3x times that term, right? Now, so what is this equal to? Well, let's begin with this, right? 3x times x gives us 3x squared. Now notice, before that, right, we multiply the signs, right? There's a positive sign here, and there's a positive sign in front of this one. So positive times positive gives us positive 3x times x, 3x squared. Positive times positive plus 3x times 3, it gives us 9x, right? Can we further simplify this expression? Yes or no? No. Why? Because these two expressions are not like terms, right? Although they have the same variable, they do not have the same exponent, so we cannot add them or subtract them, right? Okay, so that you are probably used to that already in previous lessons, but let's start looking at other examples, such as this one. All right, we have b and x plus 3 times x plus 2, right? Now these are two binomials that we're multiplying, right? These are two binomials that we're multiplying. So we use the distributive law as well, but how do you use it? Using two binomials? Well, you may want to, and you may be familiar with this, with the FOIL method, right? The FOIL method, right? And I'm gonna write it in different colors. Hopefully you can notice this on the video, right? I'm gonna use green here, and I will use black, right? And what these stand for are basically for first, right? First. So you multiply the first terms, right, on each, then you multiply the outer terms, then you multiply the inner terms, right, the terms that are inside, inner terms, and then you multiply the last terms, right, the last terms, right. So that means, using this method, right, you multiply the first terms. So what is the first term here? X on this binomial, and the first term here is x as well. So this is what it's saying. You multiply these two first, right? Let's put an arrow there. Now you multiply the outer terms. What are the outer terms on this whole thing? Well, x is the outer term because, well, it's at the beginning, and 2 is the outer term because it's at the end. So the terms that are on the outside. So then we multiply x times the 2 there, right? Now let's multiply the inner terms. The inner terms, that means the terms that are not outer, of course, but inner, inside, right? So, right, you multiply 3 times x, and then we multiply the last terms. So the last terms are, well, the last term on this expression is 2, and the last term on this expression is 3. So we do 3 times 2. All right, this is the FOIL method. So you may want to use this to help you in with the multiplication of two binomials, right? So let's do this. Let's multiply the first terms then. Equals, right? Remember equals in front of this expression. So what's x times x gives us x squared. X times 2 gives us 2x, right? So x times x squared, we multiply the first terms. X times 2, now we're multiplying the outer terms, gives us 2x, right? 3 times x, let's multiply the inner terms. What's 3 times x? Positive times positive, positive. 3 times x, 3x. And the last terms, positive times positive, plus 3 times 2, 6. Alright? Now we continue doing this, and we always have to remember this. When we expand expressions, we have to collect like terms and simplify them. So let's simplify this. This becomes x squared. Any like terms to this one? No. 2x plus 3x. 2x plus 3x gives us 5x, right? Plus 6. Right? Can we further simplify this? No. All of these are not like terms, right? So that's it. We're done with that one. Right? Once again, you may find this method helpful. You may find the FOIL method helpful when solving your problems. Alright, let's look at some other examples, some that are a little more involved. Right, let's look at C here. And it says 2x plus 1 times x minus 3. Alright, 2x plus 1 minus x times, 2x plus 1 times x minus 3. Alright. Okay, so same thing, right? Multiply the first terms. Right, we have two binomials. Let's multiply the first terms, right? 2x times x. Let's multiply the outer terms, right? 2x times minus 3. The inner terms, right? And the last terms. Same thing again. Let's start developing our solution on this one. So, same thing, equals, right, let's bring this down a little bit, equals 2x times x, 2x squared, right, 2x times negative 3, positive times negative, negative, 2x times 3 gives us 6x, right, then positive times positive, let's move to the inner terms, positive times positive, positive 1 times x, x, positive times negative, negative 1 times 3, 3. Right, next, let's collect the like terms, and that's it, 2x squared, no like terms to this one, minus 6x plus x, minus 5x, right, and then minus 3. Anything else we can do here? No, we are done. Right. Okay, let's look at some more examples. Right? And then I'll let you try some on your own as well. Right? Okay. So yes, let's look at example D here. Right? We have 2p minus 7q times 2p minus 5q, right? If it helps you to draw the arrows, do them. If not, then remember the order of executing these, right? It's important not to lose track of those things, right? I still do it here in a different color, right? Just to show you. So this times this, right? Then we're gonna have this times that, minus 7q times 2p, and then minus 7q times minus 5q. Alright. So now let's look at this. So 2p times 2p, positive times positive, positive. 2p times 2p. So 2 times 2, 4. Let's start with the constants first, and then now the variables. P times p, p squared. Remember, you add the exponents. There's a 1 there, there's a 1 there. Implicitly, even though we don't write it. Okay, 2p times negative 5q. So positive times negative, negative. 2 times 5, 10. P times q, pq. Right? Let's move on to this term. Negative times positive, negative. 7 times 2, 14. Q times p, pq, or qp. But let's keep it in this order, pq, right? So we can easily tell the terms that are alike, right? And then the last term, let us not forget, negative times negative, positive. 7 times 5, 35, and then q times q, q squared, right? Next, let's collect the like terms. We have 4p squared minus 10pq minus 14pq. That gives us minus 24pq plus 35q squared. And we're done with that one. No like terms here, right? They're all not alike. So we are done with that one. Now let's take a look at few more, right? 2 more examples. All right, let's take a look at 2 more examples, and let's move this up. So let's take a look at 2 more examples, and these are the following. All right, we have E 3 minus 2s, and then 2 minus 3s. Alright, same thing again, right? You're gonna multiply this times that, keep on doing the arrows, right? If it helps you, very useful. And then move on to that example, right? So in fact, since I'm running out of time, I just want you to work on this example, and then we'll take it up. And then of course I want you to also work on this other example, which is negative 2t minus r times negative 3t plus r. Right? Work on those 2, and we'll take them up next time when we meet. Right?